Hello, and welcome back to AP Environmental Science. Today we really want to discuss the difference between weather and climate. I think we use them interchangeably, and it turns out that in fact they are not interchangeable. And so the first thing we want to do is talk about weather. What is weather? Weather are the daily changes in temperature and moisture around you. So that's going to be how hot or cold it is, how humid it is it raining, right? Is it windy, whatever. And I think this is really interesting because obviously weather is going to be different in different places. So this is the forecast for the weekend of Labor Day 2014, and here you have the same time period, the same prediction. There it is, Labor Day. And these are radically different temperatures. This one is clearly nicer than this one, unless you really like the heat. This is for Dallas, and this one is for Anchorage. And so the question becomes, why are these so amazingly different, right? I mean, you're talking like 30 to 40 degrees. Well, it has to do with the temperature of the air masses. And if you think back to those atmospheric cells, those convection cells, they are going to tell you exactly why this is happening. So up here you've got a cold air mass, and then you have kind of like a little warmer band, and then it gets warmer and warmer as you approach the equator. And if you look, here's Dallas and here's Alaska, right? And so they're going to be totally different. And in the United States, we actually have 6 air masses, and those big convection cells are broken up into smaller air masses within those, because it depends on where continents are and what ocean currents are like and all this good stuff. So our 6 air masses here, we've got 3 tropical, those are going to be warm, and we have 3 polar, and those are going to be cold. And actually, if you look at the way that they blow, it reflects the movement of each of those cells, the mid-latitude spheral cells, and then the polar cells, because you can see this is sweeping southward and these are sweeping northward, and they actually collide. And one of the things that's interesting about our weather is we have very unpredictable weather because we actually are at kind of this collision point for these 3 air masses right here. And it's one of the reasons that it's so hard to actually get a forecast that's for more than a couple of days out when you live here. That's not true in other places, by the way. I mean, some other places, some are, some aren't. But the interesting stuff in weather is going to happen when these air masses run into each other. And so when you have a warm air mass and a cold air mass and they hit each other, you're going to have condensation, you're going to have changes in pressure that cause winds, and that can get kind of exciting, actually, if you are a weather person. So here's my first question. Which of the following natural disasters causes the most deaths per year in the U.S.? Well, let me give you a hint. We are talking about weather, so it's probably severe weather. That would be the answer. So severe weather, this is the stuff that people get super excited about or afraid of, or any of those other things. But this is when you have all of these air masses, running into each other and producing pretty violent outcomes, right? And so natural hazards, we are subject to natural hazards all over the world. Humans are. In the developed world, they are not as severe as they would be in the developing world because we have technology and we have response systems and all of this good stuff that helps kind of buffer that from us. But still, these are huge, massive forces of nature, and they're going to be a problem. And the big forces of nature that are going to be problems for us typically are going to be weather. And if you look at this, winter weather, flooding, that's weather. Heat or drought, that's weather. Hurricanes, tropical storms, weather. Lightning, also weather. Severe weather, weather. Tornadoes, weather. Storm surge actually is part of the hurricane, tropical storm, Noreaster thing. And then wildfires. A lot of wildfires are actually caused because there are drought conditions. And so you've got a lot of weather stuff. But I thought I'd start with the basic, and that is just rain. When you have lots and lots of rain, you have a couple of issues. That would be flooding and mudslides. And flooding is going to be problematic because obviously you've got fast water. It's going to cause erosion. It can cause property damage. But it also will flow into industrial facilities, into sewers, and it'll carry all that contaminated water everywhere. After the flooding after the rains have stopped, you get this stagnant water that can breed disease, and so there's all kinds of problems with that. And then you can also have, along that erosion front, mudslides. And mudslides can actually cause whole entire hillsides to slide down the mountain, and this is in mountainous areas, obviously, and that can be really problematic for the people who live there, right? Now, in some cases, the rains, we have kind of unpredictable rains. I mean, we have rainy seasons, but it doesn't mean you're going to get rain every day, and you may go the entire season without any rain, depending. But in some parts of the world, there are predictable rain cycles, and one of those big predictable rain cycles is going to be the monsoon area, and that is going to be over on the Western Pacific, right? That area around there. And so you've got these very predictable several months of rain, and it rains and rains and rains and rains. And this is actually a picture taken during a monsoon. This is just, rainstorm, children, whatever. Now, your second question is this. Has to do with floods, right? So in lots of areas, when it rains heavily, you're going to get floods, and that means that you're going to be, susceptible to all of the things that come with floods. So why would people settle in floodplains? The soil on the floodplains is fertile. The terrain on the floodplains is flat. Floodplains are close to rivers. Well, floodplains are close to rivers. They're the flat areas surrounding rivers, and they're really only inundated with water during floods, and that typically, as it spreads out, is going to slow down, and when it slows down, sedimentation occurs, and the sediment settles out, and it builds these beautiful fertile soils, and so you have these big floodplains that are great for agriculture. So 1, 2, and 3, actually all of those are the answer. Okay, now, what happens when your rain turns into crazy, horrible town, right? That is the thunderstorm. This is a special kind of rainstorm, and we in Texas are really, really familiar with the thunderstorm because I would say, and this is only my own speculation, but I feel like most of the rainstorms we get, probably thunderstorms. Now, thunderstorms, lots of issues with this. You not only have the heavy rainfall, so you've got the flooding, but typically it's really heavy rainfall, and so you get flash flooding, right? Everything's fine, and all of a sudden a wall of water. You also get hail, and hail can range from tiny little pebble size all the way up to baseball size, and you can, if you've been through hail, there's lots of damage, and if you haven't, and you live here, you will, so just hang on. Now, lightning is the other big problem. These are the electrical discharges that are coming from the clouds, and they're a big killer, right? I mean, obviously, you've got like 1,000,000 volts going on there. High winds, another really big problem. And in thunderstorms, you actually have 3 kinds of sets of winds. You've got your just regular old straight line winds. That's the wind that's blowing during the storm. That can cause damage. You've got downdrafts, and these are also straight winds, but it's a massive burst of wind with a huge force behind it that comes out of the clouds, and those are called downdrafts. They come in microbursts or macrobursts, and that's based on how big they are. I think it's like 2¼ mile or something, like 2.5 mile width is the cutting off point, but you don't need to know that. And then the last one, of course, are tornadoes, which we will talk about in just a second because they're kind of a special natural hazard. Now, the results of these storms per year in the United States, we have about 152 deaths and $12.5 billion in property damage. And this is going to be every year because these are happening every year. Now, there can be, some would consider the large influx of water to areas as a benefit, but unfortunately, really most of that water that's coming in is going to be fast water, and so it really does more erosion damage than it does. Okay, so in the vein of thunderstorms, let's talk about deaths from lightning strikes. Which state has the most lightning strike deaths? Well, living in Texas, we get lots and lots of thunderstorms, and so we're tempted to say maybe Texas, but it's actually Florida. Florida is the lightning capital of the U.S., and when you start looking at fatalities from thunderstorms, and some of that is definitely caused from lightning, some is tornadoes, and we saw that mortality chart, so you know this, but it turns out that Florida actually has, we're second for fatalities in Texas. Florida has over twice as many deaths as we do, and so they are definitely going to be the ones who are most affected. But you can see, right, you've got Tornado Alley, and then you've got all your southern states where it's hotter with your thunderstorms and things like that, and so this is where the majority of your highest are going to be. Okay, now tornadoes. These are the big rotating winds, it's the spinning winds, they're high winds, minimum 65 miles an hour. When you start talking about the big ones, you're talking about 200 plus miles an hour. That's going to be a 5. And this is actually an example of a 5 right here. I mean, this thing is like 5 miles wide. It's crazy. This was actually the 1997 tornado in Gerald, Texas, that did massive amounts of damage and pretty much wiped out half the town. This is Gerald when the tornado was done, and you can see that it wiped houses all the way down their foundations. Now, not all storms are going to be F5s or EF5s. That's the Fujita scale. Those are going to be the biggest storms. We get lots and lots of tornadoes. We are right in the middle of Tornado Alley. So while Florida may be the lightning capital, the Great Plains, this is where all your tornadoes are going to happen. And this, I actually love this picture because if you are familiar with Dallas, this is where the Rough Riders, our minor league baseball team, plays, and this is up in Plano, Frisco area, just off the tollway. And this is a tornado that is happening while they're playing baseball, and probably you should do something about that, but I guess we're so used to it that nobody did anything. They all just kind of sat there. But anyway, I just think that's a great picture, and it illustrates what I'm talking about. Anyway, so moving on from tornadoes, here's your next question. The Fujita scale that I just mentioned, that Gerald storm was or tornado was a 5. What does it quantify when you say, oh, it's a 5? Is it the diameter of the funnel, the length of the time on the ground, the extent of the damage caused by the wind, the speed at which the funnel travels along the ground? The scale is going to kind of reflect the diameter and the length of time and the speed and all that good stuff, but really what it's measuring is the damage, right? The higher the number on the scale, the more damage it's going to cause. Okay. So let's move on to cold stuff, right? We're talking about kind of warmer weather here. But don't forget that when it's really cold, you get blizzards and ice storms. And we get those too, actually, where we are. But these in the United States are going to be happening, obviously, in the north and northeast. Major issues here, heavy snowfall, ice, right? Ice accumulation and all this good stuff, and extreme cold. And you can get several feet of snow in a single event. It's huge. Snow is very heavy, by the way, and so when it sits on top of things, it can cause damage. Now, the nice thing about snow, though, is it'll melt and infiltrate into the ground if you have infiltratable, right? Permeable is the word we're looking for. Permeable stuff underneath it, and so there is that little benefit there. Okay? Now, Noreaster, which you find, as being a big storm. So what is that? Hot, dry winds on the west coast that blow towards the northeast. Warm winds, rarest in the winter and early spring. They often bring heavy snowfall, or they often occur in the southern states. Well, when we start thinking about what we're talking about, and if you've ever been through one, a nor'easter is kind of like a combination of a mini hurricane and a blizzard all together. And so they bring in heavy snowfall. But the thing about a nor'easter is it's also got the high winds of a regular storm. It's got the heavy precipitation of a regular storm, and that can be either rain or snow, right? It's got heavy seas, and you can see these are, huge winds breaking, waves breaking over the lighthouse, and here they're breaking up over the coast. And then you can see this poor little boat here in the Grand Banks is having all kinds of problems. The other thing that you're going to get is the storm surge. And we're going to talk about storm surge more when we talk about hurricanes, which is coming right up. But that's where you have water, and this is actually probably the beginning of the storm surge for this one. But anyway, so lots of snow, right? Lots of water. Now that brings us to kind of the queen of all weather, and that would be the hurricane, right? The hurricane is going to be the monster in weather. Now, they actually distribute energy from the tropical regions to the mid-latitudes, and so they're like a balancing act, right? So they actually provide, or they're forces of equilibrium in the environment. For us, they're forces of massive destruction, and we have to deal with the heavy rains and the flooding, the lightning. They spawn tornadoes, high winds. They're going to be a minimum of 74 miles per hour, and then the Category 5 storms are 155 miles an hour plus. They can spread out thousands of miles across, and so you can get huge storms. They can be small or a couple of 100 miles across, but these are big, right? These are really, really big. And the other really huge problem with a hurricane is the storm surge, okay? And I don't actually have any pictures of hurricanes because since we live in Texas, we know all about hurricanes. We see them on the news all the time. But I do want to talk a little bit about the storm surge. In here, in the eye, this is low pressure, and so it's high pressure around here. And what happens is you get this little bulge in the water where the water level is actually higher in the eye of the storm, in the center, as you approach the eye of the storm, okay? And as that comes in, so that actually gives you this kind of push of water. As this moves, there's this big push of water that's higher, and so you get large amounts of water coming on the coastline. And it just kind of sweeps over. It's not a wave, it's just higher water that just comes in and comes in and comes in. And more deaths are actually caused by the storm surge than any other part of the hurricane. And we'll talk about hurricanes a little bit more off and on, but we're probably pretty familiar with both tornadoes and hurricanes. Okay, now, what ice hurricane? What? That is crazy. It turns out that in the Bering Sea, which is on the Pacific side of us, near Alaska and Russia and all those areas, they get storms that are like hurricanes, but they're like nor'easters. So it's this weird nor'easter, blizzard, hurricane combo. Okay, and so they have these giant Bering Sea storms is kind of what we call them. But the big issues, and you can see it's got some interesting spin. It definitely gets some rotation, but it doesn't get an eye most of the time like the hurricanes do. But you're going to have heavy snowfall, high winds, lots of ice, heavy seas if you're a boat like this one, and again it's got storm surge. So nor'easters, hurricanes, and the North Pacific storms all have storm surge. And if you watch Deadliest Catch, every season they have some sort of ice hurricane, so I highly recommend you watch it. Okay, now on the other side, we've been talking about a lot of water, but you know what? Weather doesn't just mean having water. Sometimes it means not having water, and in that case, we can talk about two things. One, we can talk about extreme heat, and usually with extreme heat, you get extreme dryness, and that brings droughts. So you're going to get drought, which is the water shortage, and you're going to start having dry vegetation, and that is going to lead towards wildfires, which we'll come back to. But I do want to point this out. As things start drying up, this is a nice little riverbed here, you get shallow, hot, standing water, disease. Anytime you've got standing water, you will have the potential for disease-carrying vectors to breed. Okay, wildfires. This is becoming a much larger problem, and you can see these are some of the big ones that you see. Most of these are actually these are all California, and you can see the fire just rages and sweeps through the area. And we will actually talk about why these fires get so big and what the environmental issues with the fires are later on. But I wanted you to know that they are going to be one of the natural hazards associated with dry weather. Now, climate is the other thing that we want to talk about. And climate is the long-term weather pattern, okay? And so climate is going to be 10, 30, 50 years, right? So this is years and years and years of trend. I mean, you can't really tell what a climate pattern is going to be like in just 10 years. You really need more than that. Okay, so here's your next question. Local climate is produced mostly by all but which one of the following? The amount of solar radiation reaching the area, the Earth's rotation, global distribution of land masses and seas, or humidity? Well, it's really going to be the Earth's rotation matters not at all. That's day-night, okay? But how much heat you're getting in, how much solar radiation, that's huge. Where is your land versus the ocean? That's going to have wind pattern ramifications, and how much moisture there is. That's a huge thing too. And when you put that whole picture together, you actually get this climate map, right? And you can see here are the main climates, and then here's the type of precipitation, here's the temperature, okay, this one. And so each climate has three things. The actual overall where it is in the world, then moisture, temperature. And there's 16 of these classifications. You obviously do not need to know all of them, but you are going to need to be familiar with some of them, and we will talk about them a little bit more later on. Now, climate change affects daily weather. And we're going to talk about climate change a number of times throughout this course. We'll have a whole little just conversation about climate change itself. But I do want to talk about weather, because climates change. Right now, it's an anthropogenic climate change, but in the past, it's been a natural climate change. And so weather is going to be affected anytime that happens. Now, when you start looking at climates, I like this map because it actually shows you when the areas will officially depart from their normal climates. Okay, and you can see they're pretty much, some of them near the equator are in that process right now, and then as you move further up, you're going to have some more issues with that. But basically, what's happening is we're getting really much warmer at the poles, and then everything else is starting to change. But it isn't just about warm, right? Remember, climate is about moisture too. And so we saw changing precipitation when we were talking about, we will talk about changing precipitation when we talk about global climate change. But one of the things that's going to happen is you're going to have changes in precipitation intensities. And that is a huge factor in terms of talking about climate change. And so when we talk about, this is already happening actually, and so the percentage change in heavy rains, right, it's over 25% right here in the southeast, right? In the Great Plains area, it's 20%, right? And so we've got huge shifts in where the water is going, but also how much at a time. This doesn't mean that we're getting more rain, but what it does mean is that when it rains, there is more rain at that time, and that's very important for you to think about. And this I've just put in here for you to kind of look at, okay, what's going to happen, what are the impacts, right, as we start projecting out as the climate changes, okay? Now, back to hurricanes, right? If the global climate is getting warmer and hurricanes are a distribution mechanism, then one would think that there would be more and stronger storms. However, there is some evidence that it's related, and then there's some evidence that's not. And so one of the things we are not going to talk about when we talk about global climate change are hurricanes until we have some sort of better understanding of that whole connection. And there's a couple of things we'll talk about that probably should be affected by global climate change, but we can't actually see the direct link. Cyclones are going to be one of that. Remember, hurricanes are called hurricanes, cyclones, and typhoons, depending on where you are in the world. That's just for fun knowledge. Okay, and then the last thing I put in here are some resources for you to go and look at the various weather phenomena that we talked about today. If you have any questions, please ask me in class, and thanks for listening. I will see you next time.